And so next this year we work with Molinos and Pablo to do the yield prediction and the protein estimation. And that's when we ask for help from Aria Imaging, because I think he will explain it better than I. There are a number of advantages on using aerial imagery, and especially this unmanned aerial vehicle technology that's coming up. That's being brought to market. So I will, before I go into the protein estimation, I will switch the screen to Eric, and also introduce Eric, who is an agronomist and remote sensing expert. So it's a rare combination. Born in Belgium, and he studied in Wageningen Agronomy University. That's very close to where I studied. I studied in Enschede. It's about half an hour away. But we met in Argentina, so that's how small the world is. And so I will switch the screen to Eric, who has part of their own company that's focused on the development of unmanned aerial vehicles and remote sensing technology. So with that, I'll switch the screen to Eric, and thank you for being here, Eric. And I will unmute your microphone, so there you are.
Hello, everybody. First of all, thank you, Paolo, to include us in this presentation. And I will explain the use of unmanned aerial services for agro. It's a bit broader than just UAV, which is more commonly known, unmanned aerial vehicles, because it's not just the flying vehicle, it's a whole more other kinds of service, just because of the other different kinds of image processing, other kinds of advantages, other kinds of problems we are facing as well. So our company, we are in fact a remote sensing company, putting our attention on agricultural application, environmental applications, mining, and urban applications. But we are more focusing on the agriculture part. It's also the most complicated part, and also the most interesting one. So in this presentation, we will focus on, in the framework of this topic, on this seminar, for agricultural applications using the UAV's imagery. Our company, we used to work also a lot with satellite imagery, but we started to facing the problems to obtaining the imagery, and 3 years ago we started to develop our own vehicles and reorientating our company towards the UAVs. This picture, you know for sure, which explains a bit how is the data processing flow. It all starts with the data collection, being satellites, UAVs, or in situ measuring, as in this case you can see on the picture with the SPAT meter. Then from that imagery, we need to do some data processing, starting from the multispectral map to make an index map, as in this case, as Paolo has been explaining, with the NDVI maps from 2010. And these we should convert them into useful information as a task map for refertilization, for protein estimation, and then that's what Aria Imaging is doing. The number 1 and number 2. Then the data distribution, the end user takes the decision, and the implementation, that's something we don't do, but which is entirely part of a process of site-specific management. So we are, the company is founded in 2008. We are, in fact, I'm from Belgium, but we have also people from Spain, from the Netherlands, and here in Argentina we are also working with local people, experts in geomatics, remote sensing, land survey, and today we are in Belgium, Argentina, and Spain. This gives some advantages on us because we can work the year round with the northern hemisphere, the southern hemisphere, and get some experience with Mediterranean crops like vines in Valencia. So here you can see our vehicle. At this moment, this is our UAV that we are using this year. We are still developing another one, but here you can see it's a small size UAV with electric propulsion, no wheels. This is important because we can use the vehicle anywhere in the field, especially where there are no paved roads to take off, to land. It is important that you can just throw away the vehicle, starts flying. Right now it is limited to 30 minutes flight. At 200 meters altitude we can do 60 hectares of flight with a 20 centimeter resolution. And if we fly at 1,000 meter altitude we can do the 400 hectares per flight. It is a completely autonomous vehicle equipped with a GPS and a multispectral camera. As you can see in the picture left, it has 6 lenses, so it's 6 different spectral bands, being the ones in the visible light and 3 infrared channels. Very small band, which enables us to make different kinds of indexes. This is going to be the new vehicle we can where we will work with starting from next year, and which will be also equipped with a thermal camera. Thermal camera is something we don't have now, but in the future can be useful for water content and for different kinds of plague detection. The flying autonomy will also be larger than the Maya, which is our current vehicle. They are all hand launched and land on the belly. These are some examples of the imagery we can take with this Tetracam, the camera we are showing here. So we have 6 bands with different kind of filters we can choose. On the bottom line you can see the filters we have here. 470, which is blue light, and 810, which is infrared, and everything what's in between. So we can make many different kinds of indexes. So unlike NDVI, we can differentiate using different kinds of indexes between biomass, health of the plant, nitrogen content, which now all these 3 variables are included in what we call NDVI, which is the greenness of the vegetation. So why do, I think this is a question many of you have asked yourself already, why use precision agriculture? Maybe it's not needed to explain this here, but matching the farming practices more closely to the needs of the crops is becoming more and more needed, and now with the availability of these new technologies we can start to apply them also to reduce environmental risks and footprint in farming, limiting leaching of nitrogen, boost competitiveness through a higher efficient practice and better management of nitrogen. This is quite focused on nitrogen, no? But we have also, of course, other applications like the use of agrochemicals, and as Paulo was explaining, the estimation of protein content in wheat. So what is important here? It's maybe not the resolution of the imagery, but maybe the exact timing of when we are measuring our crop, in order to that the imagery can be useful for our day-to-day practices in farming. And this is where we can control better with the aerial imagery, because we are not depending on the clouds and not depending on with manned aerial flights to large programming of the flight, depending on flight regulations, occupying of the airspace. Especially in a dense populated area, it's sometimes a problem to fly. But maybe in US, Argentina, it's not that kind of a problem. So here we have some example. This we did in July in Holland. This is a field with potatoes, and what we see here is a biomass index from June 28 and another one in August 16. The red part in the middle is an area without fertilization. So this is also used in a kind of setup to see what we can take out of the imagery. This map is used to make a task map for potato haulm killing. So this means that the plant needs to be, the leaf of the plant needs to be killed in order that the potatoes can give the last boost. So this task map, this UAV imagery is used to build a task map to apply chemicals to the crop. For nitrogen fertilization, we can do this in the same way, where initially we throw 150 kilograms of KIS everywhere. Using imagery, we can apply distinct rates. So this strategy is based on plant set field measurements, collecting in a database per plant species. So in this case, it's also for potatoes, so it's depending on the potato variety and per region. So this is another example we can, which is valid for potatoes, but also for maize, for corn, I mean, or wheat. So other things we can do with our imagery is damage assessment, like salinization monitoring, plagues on the left side, on the right side image. This is a normal picture, but we hope that with the thermal imaging images we can determine better when there is a problem in the crop, because the plague is not immediately visible in the NDVI of an image, and that the leaves are getting brown because of a plague. Then it's in fact already too late. Before it is too late, the plant's getting in a stress. It's getting fever. Evapotranspiration is halted, and the plant gets warmer. So this year we will try to fly with thermal to try to determine early stage of plagues. This is an example of vineyard monitoring, different kind of applications. So here we are going to compare UAV and satellite images. I think they are very complementary. Because with satellite imagery, we can cover very large areas. There are few problems with geometric corrections, especially for agricultural applications where the precision is not that important, because we are talking about fairly large fields in this case of wheat. But the big advantage of UAVs is that the full control of the acquisition time. The only day we cannot fly, in fact, is because of the wind. When there is a very strong wind, you can't fly. Especially we notice in Argentina, it's sometimes a problem, in fact, that it's many times we have lots of wind here. Then we can choose the different spectral bands depending on the application, because now we are stuck to Landsat or Spot or Rapid Eye with a fixed amount of bands, and that's it, and we have to extract what we want with what we have. So here we can start making new combinations, starting experimenting what combinations we need for what kind of application. Another important thing is that the flight is underneath the clouds is possible. Because in many cases, I don't remember the real statistics, but it might be in 25–30% of the cases, imagery cannot be acquired because of clouds. And as it is increasingly important to acquire images at in a determined time frame, it's going to be important to think about aerial images. And of course, we have a much higher spatial resolution. So this is about it. You can find more information on the web page, and I would like to pass again over to Pablo for the rest of the presentation. Thank you very much.